Okay, let's see how to solve this system right here using inverse matrix method. Just to review the method right in here, if we have matrix A times matrix X, and that equals matrix B, if we multiply both sides of this equation by the inverse of A, keeping in mind that matrix multiplication is not commutative, so we have to multiply on the left side. A inverse times A will give us the identity matrix, and then this matrix will equal A inverse times B. So that's what we're trying to do. So for this system of equations, matrix A is the coefficients of x and y, 5, 6, minus 1, 4/3, minus 7/2. Matrix X is the variables, x and y. If we did multiply A times X, we would get the left-hand side of those equal signs there. And matrix B is what we end up with, negative 18, negative 44. So this block right here shows us how to calculate the inverse of matrix A. First thing we need is the determinant of A, which is multiply this way for a 2 by 2, and then minus multiply this way. So if we do that and simplify, we get negative 19/12. Now to find the inverse of a 2 by 2 matrix, you take the reciprocal of the determinant. So that's 1 over negative 19/12, which will eventually become negative 12/19. And then to get the matrix part for the inverse, we interchange along this diagonal. So 5, 6 moves to here, negative 7 moves to here, and we take the opposites along this diagonal. So negative 1 becomes 1, 4/3 becomes negative 4/3. And then here's the reciprocal, the scalar multiple, and then we take the scalar times each element of the 2 by 2 matrix. This is what we get right here. Unfortunately, this is not a simple calculation, but now here we're going to take A inverse times B, and that means we take the first row times the first column of B, and adding them together. So 42/19 times negative 18 minus 12/19 times negative 44. That's going to be the value of x. And y is going to be when we multiply the second row times the first column of B. So 16/19 times negative 18, negative 10/19 times negative 44. I don't want to work that out here, but I'll go to board 2 and show you what I got on Desmos. There it is. So it looks like x is negative 12 and y is 8. And of course, we should probably check those in the original equations, but I'll leave that to you. There you go. I hope that helps. If you have any questions, post a comment.